I welcome you all for this presentation. In this presentation, we are going to discuss about linked list implementation of queue. This is the overview of this presentation, the basic idea behind linked list implementation of queue, then the basic operations like EnQueue operation, DeQueue operation, then algorithm for EnQueue operation, DeQueue operation, then implementation using C and implementation using C++, followed by summary of this presentation. So the basic idea behind implementing this queue data structure using linked list is we have to create a linked list. For each and every element, if we want to insert, we have to create a linked list. So we are creating a linked list to which items would be added to one end and deleted from the other end. We are all aware that in a queue data structure, we need to maintain 2 pointers. One is for the insertion purpose. For insertion, we are inserting at the rear end, and for deletion, we are deleting at the front end. So we are creating a linked list in which items are added at one end and deleted from the other end. That way only we have to do. And 2 pointers will be maintained. One is the front pointer. Front pointer is to perform the deletion operation, and another pointer is to perform the insertion operation. So that pointer we are calling it as a rear. So this is to perform the insertion operation. So 2 pointers will be maintained, one pointing to the beginning of the list, that is point from where elements will be deleted, that is the front, and another pointer to the end of the list, that is pointer where new elements will be inserted, that is the rear pointer. So 2 pointers we have to maintain. One is to perform the deletion operation and another is to perform the insertion operation. So what is the purpose of having a pointer? It contains the address of the another node. So this front pointer is having the address of this first node, and the rear pointer is having the address of this last node. So this pointers contains the address of the another element, another node. So coming to the EnQueue operation, EnQueue means it is a insertion operation. Insertion only we are calling it as EnQueue operation. So in the EnQueue operation, where we are performing the insertion or EnQueue operation, always it happens at the rear end only. So if we want to insert an element, this is the new element we are going to insert. If we want to insert, what we need to do is we have to remove this null to point to this one. So because this was the last element earlier, now we are going to insert, and always we are inserting at the end only. So the null, always the last node contains null as the address, because this is in order to demonstrate that it is the last node. So we are having a null only. So the null pointer we are pointing to the next node. Then we are making this rear pointer to point to this last node. This is about the insertion operation. Next is the DeQueue operation. So where we are deleting an element, always we perform deletion operation at the front. Deletion happens always at the front only. So in order to delete this element, this front means the first element only, always we are going to, our first node only we are going to delete it. So in order to delete it, we have to free off that particular node, and we have to make the front pointer point to the next node. So this way only we are performing the deletion operation or DeQueue operation. Let us see the algorithm. So here first we have to include all the required header files and user defined functions, and whatever the variables we need, everything we are going to declare it and we are going to include it. Then we need to define a node structure, because this is a linked list implementation. So we need to define a node structure with the 2 data members, data and next. Here we are implementing a single linked list. So always for any node we are having 2 compartments. One is for the data and another is for the pointer. So next. So we are defining node pointers called front and rear, because this is the implementation of queue. So always for the queue implementation we are having 2 pointers. One is the front and another is the rear, and both we are setting to null. And we are implementing the main method by displaying the menu of list of operations, and we are making suitable function calls in the main method to perform user selected operation. Next is the insertion operation, that is EnQueue operation. In always EnQueue or insertion happens at the end of the list. We all know that end of the list means the next pointer is null. That is the end of the list. Always we know. So here only at the end only we are going to perform the insertion operation. So what we need to do is whatever the element we are going to insert, we are creating a new node with a given value and we are making the new nodes next to pointing to null. Now this is the new node and we are making this new nodes next to point to null. And then we are checking whether Q is empty. Q is empty in the sense rear equal to null. If rear equal to null, then Q is empty. But here rear is not empty. So then what we need to do is we have to make front equal to new node. Suppose if it is not empty, then we have to make front equal to new node and rear equal to new node. That is, this is the first element we are going to insert. If it is empty means, if there is no node in the linked list, then we are just making that whatever the node we are going to insert as the first node. So we are making front equal to new node and rear equal to new node. Then if it is not empty, then what we are doing is we want to insert at the end only. So rear point to next equal to new node. So here what is rear now? Rear is this one. Earlier case only we have to look into. So the rear's next, this next we are making it as a new node. So in the rear next in the sense some address of this new node. Say for example the address of new node is 500. So the rear point to next we are making it as 500. And now this rear, whatever the rear pointer we are having is, that rear we are making it as a new node. So this now this becomes the new node. So rear is also a this also we are making it as 500. So here rear point to next equal to new node. Here we are just writing the address of the new node and now we are making this rear equal to new node because rear is also a pointer. This must contain the address of the last element. In the queue data structure, we are having two pointers, front as well as rear. Front is having the address of the first node, say for example 100 means the 100, and the rear is having the address of the last node. So now while inserting any element, what happens means we are just making rear points to next equal to new node. So rear point to next, this contains the address of this node and now the rear point contains the address of the last node. Always we have to maintain two pointers, front and rear. So now we are having this value. Next, coming to the deletion operation, we are checking that whether Q is empty or not, that is front equal to null we are checking. And if it is empty, then we are displaying that Q is empty, so we can't perform any deletion operation. If it is not empty, what we need to define is, we have to define a node pointer temp and set it to front. So deletion in the sense, always the front only we are going to delete. The first element only always we will be deleting in the queue data structure. So the first element we are deleting. So we are making a temp pointer and we are sending that temp to a front. Then what we are doing is the front we are making it as front point to next. Whatever we are having the next, that we are making as we are assigning it to front. Then we are deleting that temp. So this is the temp, this is the first node we are going to delete. So the front pointer is pointing the temp operator. So what we are doing is the front point to next, we are making it to assign to front. Then we are freeing off this one. So this way we are performing the deletion operation. Next is display, that is we are displaying the contents of the elements of the queue, that is we are checking whether queue is empty or not. That is front equal to null we are checking. If it is empty, then we are displaying that queue is empty. If it is not empty, then we are defining a node pointer temporary. From first to last element, we have to traverse and we have to display the contents of the queue, the linked list. So queue data, we are just displaying it. So display temp point to data equal to all the elements and move it to the next node. Repeat the same until temp reaches rear. That is up to the last node it reaches. We have to display the content of the queue. Next is the implementation using C. So all the required header files we have to include. Then we have to create a node called struct node. We have to create struct as a keyword. Many times we have discussed that. Node is the name of that particular node. And in the linked list, we know that one node consists of data as well as the pointer. Pointer contains the address of the next node. So here we are having 2 pointers because this is the queue implementation, right? So we are having 2 pointers, front as well as rear. In addition to this, next we are having front as well as rear. And first we are having a empty linked list, so front equal to null and rear equal to null. Then we have declared whatever the functions we are using. We are using the insert operation, delete operation, then display operation, then main function is there. It is a menu driven program. All are aware of the menu driven program. Let us see one operation. For insertion, first we have to create a node, new node, and new node equal to a malloc function you have to use. So the syntax of the malloc function is new node equal to struct node star. We already defined the structure, right? So struct node star malloc size of the struct node. For one particular node, we are allocating the space in the memory. Then what we are doing is we are just assigning the value to new point to data. Then we are making the new node next pointer to null because only one node we inserted. So it is null. And if front equal to null, what we need to do is there is no element or no node in the linked list. So we are making that front equal to rear equal to new node. This becomes the first node. So only we are making front equal to rear equal to new node. Suppose if it is not the first node, then what we are doing is new node equal to rear point to next. Always insertion happens at the rear position. So we are assigning new node to rear point to next, and now we are assigning the new node to rear. So insertion happens successfully. Next, in the delete operation, if front equal to null, then we have telling that queue is empty. Otherwise, what we are doing is we need to define one temporary variable or temporary pointer here, and we are assigning the front to this temporary pointer. Then we are making front point to next is assigned to front. Then we are freeing of the temporary variable. Already in the algorithm part, we have seen how we are deleting a node and the queue. Coming to the display, first we have to check whether queue is empty or not. If it is not empty, then we have to display one by one all the elements in the queue. Coming to the C++ implementation, here also whatever the things needed, we have to declare it and include all the header files, all those things we have to include. Then it is similar to that only, insert operation we are calling. There whatever the condition we have checked there, the same thing only here also we are checking whether rear equal to null, we are checking. If it is null, then we are creating a new node and we are assigning front equal to rear. It is the first node. Otherwise, else you are creating a new space for the new node. That means it may be some other always the insertion happens. If it is the one and only node means it's okay. Otherwise, where we are going to insert, insertion happens at the rear end only. So rear end means at the end. So only what we are doing is we are assigning the value to temp point to data and the last node, right? So only temp point to next equal to null, assigning temp to the rear. Similarly, we are having the delete operation. Always deletion happens at the front only. So we are checking whether the front equal to null or not. And first we need a pointer called temp. That temp we are assigning front to the temp. If front is not null, then we are checking that temp point to next not equal to null. That means where we are performing the deletion operation, always in the front of the queue only we are performing the deletion operation. So we are assigning the temp point to next to temp. Then we are freeing of this front, and now we are assigning the temp to front. Else we are what we are doing is the whatever the element deleted we are displaying. Then we are just freeing the element, whatever the front element we are deleting. That means this is the one and only element available in the queue. So that element we are going to delete here. So after deletion, what happens? Front equal to null and rear equal to null. So there is no node in the linked list. So all these cases we have to consider in the implementation. Then display in here we are checking that temp equal to front. We are assigning front to the temp, and we are checking that front equal to null and rear equal to null. If this is the case, there is no element in the linked list, so queue is empty. Otherwise, we are checking that while temp not equal to null. Up to that, we have to display all the elements in the linked list. So this is the main function using C++. So in this presentation, we discuss about the basic idea of the linked list implementation of queue, then two basic operations like EnQueue operation, DeQueue operation, then algorithm for this operation, then implementation using C as well as C++. Thank you.